Welcome to my 221st video on my work with OO gauge. This video will feature a little project on my Hornby Dublo 3-rail tabletop railway, installing a Dublo switching isolator track to allow me to use the center track on my Dublo turntable for locomotive parking. Let me start by trying to explain why this was necessary. Okay, let me see if I can contrive to explain the point of this little project. This is my Hornby Dublo turntable, 3-rail turntable. And it has one track coming into it, and 5 tracks going out of it. And as you can see, I've currently got locos parked on 4 out of the 5 tracks going into it. Now, in terms of power always passes from that incoming track. You don't supply any separate power to the turntable like you do with some turntables. The power comes from the incoming track. Power is always passed from that incoming track to the table, regardless of the position of the table. There's a little retaining lever here that locks the table into a position. So to turn the table, you just hold that lever down and then move the table until it locks into another position. Famous last words. It's a bit awkward to do with one hand, but there, see now that's locked in, so that's lined up with that track. And to line it up back with the incoming track, I just press the lever down and push it back until the lever snaps into place. So power always comes from there, the incoming track, to that. But then power only flows to these tracks on the other side when the table is lined up with them. Okay, so if I wanted to bring this engine off here, I would have to line the turntable up with that. Then I'd bring the engine onto the table, line the table up with the exit, and exit from it. Now, power only comes to the table at all if this point is set, because that's an isolating point. So long as that isolating point is set to turn, power goes round there and it never comes here at all. But if I set that point straight, then power will flow down here to the table. And I've got my that may not be the best engine to be doing this with, really, but anyway, I've got my streamlined coronation there. Famous last words, and we're trying to... Oh, come on. I'm trying to bring him into the table gently, which is not easy to do. Oh, do come on. I'm trying to put him on the table, but there we go. He's on the table now. Now I'm going to turn him round now. But as soon as we get to there, he locks into there, and I don't want him locked into there. So now we've got him turned around and locked in. So now, if I reverse him, famous last words, I should be able to put him on that parking track. Which is, of course, he keeps sticking because he's a bad conversion. I've converted him and he doesn't have very good 3-rail pickups. I'm just going to push him back onto that parking track for a minute. Now if I power him, will he move? Oh, no, he won't. See, this isn't illustrating the point very well because he's not working very well. He should be moving now, and he isn't. Oh, I don't know. See, now he is, but no. This is not very helpful. I think I'm going to switch to using an engine that works better for this. Alright, now I've switched to using an engine that, this is a new 264 tank, well, new to me, which has been serviced and everything. It's in pretty good condition. I actually bought it for a project. I was planning to kit build an LMS body and put on it. But anyway, famous last words. Let me try and park that. The wire to my conveyor. So see, now he's parked on there, on that central track. Now we can bring him out of the central track, and we'll put him back in the central track. Now the problem is with using that central track as a parking track is, okay, I've got him parked there, but with him parked there, I can't really effectively bring out any of the other engines. See, because say I want to bring out this engine on the next parking track, we go over here, we set that to forwards, and we bring him forward onto the table. Okay, so he's on the table, but to get him out onto the main line, I've got to line the turntable up with the main line. And now the turntable's lined up with the main line, it's also lined up with that line. So if I apply power forwards, they're both going to move, probably. Famous last words. Actually, the back one isn't moving. Actually, in fact, it worked quite well, because the front one moved a lot faster than the back one. But the problem is I'm applying power to both those engines at once, which is hardly a very effective way of doing things. And the only way to avoid doing that, it actually works better than you'd think, because the N2 moves a lot faster than this tank, so I can sort of, they're both moving merrily all the time, you see here. Well, you can't see, because you can't see the N2, but they are. There's the N2 backing in. You can see they're both moving, you see, because they're going to, because, you know, with the turntable in this position, power is applied to the table, to there, but it's also applied to there. So I can't really effectively park an engine there. This is the problem. You'd probably illustrate the problem better if the engines were the other way around, but in any case, the problem is I cannot effectively park an engine here, because whenever I'm trying to exit with another engine, power is also supplied to here, and that engine's going to move, which I don't want. Okay, to better illustrate the point, at least I think it'll better illustrate the point, I've swapped the engines round. I've put the N2 on the centre track, which tends to be the faster moving one, and the 264 tank on the other track. So supposing I want to get that 264 tank out onto the main line to use it for a train. So I press the lever and I move the track so it's lined up with it. That's all very well and good. Make sure I'm set to forwards. I move it forward onto the table. Then I press the lever again and move the table till it's lined up with the exit track. So now I'm ready to pull this engine out onto the main line. But when I do that, the problem is I'm also going to be supplying power via here to the N2. So when I go forwards, the net result is they both go out onto the main line, which is really not what I want. And as I've said before, the M2 moves way faster than the other guy. But the only way to prevent that is to put some sort of manual isolator in here, because otherwise, whenever I try and take any engine out from the table to the main line, I'm also going to move the engine parked in it, so I can't really use that track as a parking track. It's kind of useless even having it there where it is, because you can't use it for anything. It doesn't go anywhere. And I can't really park anything on it, because anything parked on it will move whenever I try and take an engine out of onto the main line. So what I want to do is put an isolator in here. That's the point. I need to put an isolator in here between the table and this parking track, so I can isolate that parking track, take engines out without that parked train moving. So that's the whole point of this project. So I hope that made the general idea somewhat clear. Now, I had considered creating a switching isolator for that track simply by doing my own modifications, creating a break in the continuity somehow, for example with an isolating tab, and then soldering wires and running them to a switch to allow me to switch the power. But Hornby themselves made something precisely for this kind of switchable isolation, and as it happened, Nigel of British Model Trains picked one up recently with a collection that he bought, and I picked it up from him at the recent Kitchener train show, and here it is, at least here is its box, part 32230, an isolating rail with switch. Here are the contents of that box. The isolating rail itself, essentially a modified quarter straight, a switch, and a sheet of instructions, sadly a bit torn from being crammed into the box with the other parts. Here's a close-up of the instructions. Pretty straightforward in concept, really. The isolating rail has a break in the centre rail, so centre rail power is not automatically passed across it. There are screw contacts on the side of the isolating rail, which connect to each side of the broken centre rail. You wire those contacts to a switch, and you're able to switch transmission of centre rail power across the isolating rail on and off. Here are the isolating rail itself and the switch. You can see the break in the centre rail. A piece of non-conductive material is inserted in the break so as not to leave a big hole that might upset the centre rail pickups of models. Here's the bottom of the isolating rail. You can see how the screw contacts on the side are connected to the centre rail sections on either side of the break. I started by preparing the isolating rail like any other piece of three-rail track, wiping the rails with fine emery paper on a wood block and then cleaning with electrical contact cleaner on a rag. When Hornby Dublo was first launched, the isolating rail was the only means provided of cutting off power to a section of your layout. All of the Dublo points, as initially made, were like this, with all of the centre rail sections, the one incoming rail and the two switchable outgoing rails, all permanently electrically connected to each other. So no matter how these points were set in terms of directing trains, electrical power was always passed across them to all of the connected tracks. So points in the initial Dublo track world did nothing at all to isolate sections of your layout. If you wanted to be able to run locomotives on your layout, whilst having other locomotives parked on the layout and not moving, the only way to do that was by way of isolating rails. So Hornby's early track plans for Dublo have isolating rails all over the place. This old Hornby Dublo booklet of suggested layouts, price sixpence, for example, contains plans such as this, which is somewhat similar to parts of my three-rail layout. Note that there are isolating tabs indicated by IT in many places, and two isolating rails indicated by short straights with broken centre rails and two dots on the side. And even this arrangement wouldn't allow you to have a loco parked in the station whilst having another going round the loop. You'd need to add another isolating rail on the station branch line for that. Not too long after the launch of Dublo, Hornby realised that they'd basically made a mistake by not providing for isolating points, i.e. points that, rather than always passing electrical power to all tracks all of the time, only pass power to a track when the point is set to send trains to that track. Here is the bottom of a Dublo isolating point. The sliding contacts are moved by the same actuator that moves the switching rails of the point, and the centre rail power will only be passed to the exit rail to which the point is switched. These isolating points made layout design so much simpler, and largely eliminated the need for isolating rails. If an isolating point was used to branch off a siding from the main line, then a loco on the siding would only move if the point was set to turn to the siding. If the point was set to pass trains straight along the main line, any loco in the siding would not get any power and would stay quietly parked. My own tabletop railway is based extensively on the use of isolating points. Here's a plan of my three-rail layout before the addition of the extra shelf for the turntable. All of the track pieces labelled IR and IL are isolating points, right hand and left hand. This arrangement allows me to run locos on my loop whilst having other locos parked in the engine shed, the goods depot and the station and the sidings. The back of the loop itself is also divided into an inner and outer section, and a loco can sit parked on one of these sections whilst another loco is going round the loop using the other section. However, this situation with trying to use the centre track on the turntable for parking was one case where an isolating point was not really suitable, and an isolating track was what was needed. I started by testing for continuity, making sure that things were supposed to be connected were connected, and that things that were not supposed to be connected were not connected. Alas, this initial test failed. The track was okay, but the switch wasn't working at all. There was no continuity between the two connectors on the switch, no matter what I did with the lever. So if I wanted to use the switch, I had no choice but to take it apart. There were two little bolts with nuts that held on the backing plate of the switch. By undoing these nuts, I was able to remove the backing plate. Here's the inside of the switch. As you can see, the upper outside contact is connected to a piece at the top of the inside of the switch, which will only be contacted by a piece mounted on the lever of the switch when the lever is positioned on the left, towards the outside contacts. The other outside contact, the lower one, is connected to a piece which in turn is connected to the pivot of the switch lever. I tested with a multimeter. Why wasn't the switch working? Well, the continuity from the outside contacts to the inside contacts was fine, and when the lever was on the left, there was continuity between the top outside contact and the contact mounted on the lever, but there wasn't any continuity between the lever itself and the pivot. So no matter how the lever was set, there could never be continuity between the two outside contacts. The pivot was basically riveted in place, so there was no easy way to remove it for cleaning. However, by spraying copiously with electrical contact cleaner, I did manage to produce continuity between the lever and the pivot, thus completing the circuit. Well, at least sometimes, although I couldn't get it to behave very reliably. I reassembled the switch, screwing the little nuts onto the ends of the bolts and thus reattaching the backing plate. Now I wanted to try wiring up the arrangement. I cut a piece of 2-strand wire to a reasonable length. I stripped the ends of the wires and got my soldering station on and tinned the ends of the wires. Next I ran into another problem. It was simply impossible to tighten the little knurled nuts on the contacts on the track enough to actually grip wires. I tried and tried, cleaning everything thoroughly and using pliers, but I simply could not force the knurled nuts to tighten enough to grip the wires. And of course, if I simply applied massive force with large pliers, that would just break the contacts off from the rail. So, since the nuts absolutely wouldn't tighten enough to grip the wires, I searched around and managed to find some small split washers. By putting split washers onto the contacts before screwing the nuts down, I was finally able to get the wires to connect to the track. Then I connected the other ends of the wires to the contacts on the switch. So I finally had everything connected up after an hour or so of struggling, but it still didn't really work. The switch could hardly be persuaded to provide a connection, occasionally after multiple tries, but mostly not. I did think of scrapping the Dublo switch and just using a suitable modern switch, but although I know I have some somewhere, I couldn't find a suitable modern switch. Inability to find things that I know that I have is sadly a more and more common occurrence. So I took the Dublo switch apart again, and after more mucking around, did manage to get it to function somewhat consistently, at least most of the time. So I was finally ready to try to install the isolating rail onto the tabletop. I started by removing the screws holding down the end of the centre parking track and its buffer stop. The rubber yoga matting that I used for the top of the shelf with the turntable is not easy to get screws in and out of. It's too sort of squishy and rubbery. Having removed those screws, I detached the parking track from the turntable, and I got the isolating track ready. I had detached the other ends of the wires from the switch, as I wanted to pass those wires down through a hole in the board. I connected the isolating rail to the centre position on the turntable, with its contacts on the far side. Then I got out and powered up my hot foam cutter using the straight rod attachment. It also has a wire attachment for carving foam. Using that hot rod, I was able to make a hole through the yoga matting and through the white insulating foam underneath that makes up the shelf. I could have used a drill, but I find that drilling through foam tends to make a big mess, whereas melting through with a hot rod is easier and neater. After a couple of tries, I was able to get the wires passed down through the hole that I'd made. Then I pulled the wires through from underneath, leaving a fairly neat connection on top, as seen here. With that done, I connected up the long straight for the parking track and then put the buffer stop onto the end and screwed it down. There was barely room before the end of the shelf. The buffer stop actually overhangs the end of the shelf, but I think it should be okay. I connected the other ends of the wires to the contacts on the switch and tested. I was able to power the centre parking track, but to isolate it by turning off the switch. The turning off was no problem. Getting the switch to actually make the connection was still a little bit iffy. I did my best to mount the switch under the edge of the shelf. This wasn't the best of arrangement, as screws really won't hold firmly in the white foam, which is quite soft. Afterwards, I used some double-sided tape to hold the switch up against the bottom of the overhead yoga matting. I'll see if that works okay. If not, I'll have to think again about fixing the switch in place. The lever of the switch just protrudes from the side of the shelf, allowing power to the centre parking track to be switched on and off from there. So that's about it for this installation. Now let me see if I can show you this working. So, I've installed the isolator. Now let's see if I can get things to work. There's the isolator track with the wire going down through the hole in the board, and we've got an engine part there, and there's the switch sort of lurking under the edge of the board there. I'm quite confident that the switch will disconnect power. I'm not quite so confident that it'll connect power, because that Hornby switch is a bit ropey. It doesn't make very good connection. It relies on the actual arm, the bit you flick, connecting to the pivot in order to complete the circuit. It just doesn't seem to connect to the pivot all that well, despite my best efforts. But we'll see. So I've got the point here set, so that will pass power down to the turntable. So first, let's try and get one of the other engines out. So we'll turn the turntable to point to the N2 here. We'll set the controller to forwards. And, okay, so there's the N2 on the table. Now we turn the table to point to the exit track. And we should be able to pull the N2 out. Well, we will. I'm fairly confident about that part. Without the other engine moving. Okay, we'll bring the N2 back again a minute. And we'll put it back in its parking track. We'll try to anyway. Oops, not too far. Now, can we succeed in bringing out the engine that's parked on the middle track? For that, we will need to operate the switch, which of course is falling off. I'm not sure what I can do about that, but anyway, let's see if it works. We've switched the power to forwards. Yes, there we go. We have succeeded in doing that, and we don't have to turn it anymore to bring him out. So there we go. Yes. So it sort of works, except in as much as, see, now he's past the isolator. So now if I flip the switch over to the off position and turn the power up, nothing should happen. No, and indeed it doesn't, because he's isolated. So it's sort of working, except that the switch is tending to fall off because it's a bit hard to attach it there, and I'm not quite sure what I can do about that.